everyone, how are you doing? Yes, give me a thumbs up, okay? Yeah, in the beginning also something happened over here. No worries, okay?
Yeah, you are so excited to see your students.
Yes, so much excited to see my students, so tongue is slipping. Alright, no worries. How are you doing? Yes, give me a thumbs up if you're doing great. Give me a thumbs up.
Yes, we have.
Give me a thumbs up. A double thumbs up. I'm expecting a double thumbs up from your students. Alright. Good. How are you, ma'am? I'm doing great. Screen is blurred. Sir, clarify that. Sir, the screen is blurred, it seems. Yeah. Good evening, everyone. So, are you all ready to begin the session? Yes, right? Yes. So, today we are going to start our new chapter, as you have seen in the thumbnail, right? Acid, bases and salts. We are going to start a new chapter, and this chapter is so amazing. This chapter is so amazing, trust me, okay? All you have to do is just concentrate on the studies. And someone in the comment box like, ma'am, please teach us rancidity and corrosion. Yes, I'll consider that, okay? So at the end of this session, I'm going to talk about the corrosion and rancidity, okay? No worries, I'll talk about that. Anyway, that topic was deleted, and some of you like that was not a deleted portion, so I'll take that portion, okay, in the session itself. No worries. Alright. So the chapter that we are going to discuss today is nothing but acid, bases and salts. So how do you feel about this chapter by hearing this name, acid, bases and salts? What do you think? Is this chapter started in your school? Ma'am, can you please unmute one for me?
Okay, yes, of course. Yes, Rashi.
Rashid.
Rashi.
Rashi. Just Rashi. Okay. Rashi.
Hello.
How are you, Rashi? Doing good, right? So, is this chapter started in your school?
Yes.
It started. So, you have a basic knowledge about this chapter, right?
Yeah.
Yes, so very good, very good. So, we are going to detailedly study this chapter, okay? We'll discuss everything, every little points, okay? So, all you have to do is just make perfect notes, okay? All you have to do is just make the perfect note, take a notebook, write down literally everything that I'm saying that is there in the slide. You're going to write down everything, okay? Will you do that for me?
Yes.
Yes, everyone will be looking at me like a serious face. Yes, why is that serious look on your faces? Yes, why so serious? No, don't be serious in my class, okay? Alright, relax, be relaxed, and we'll study them together, okay? No worries, this is a cute, interesting chapter. So here we go, without wasting any time, let's begin the chapter, acid, base and salts. Before that, do we have any new faces in our class? Do you have any new faces, ma'am? You can just raise your hand if you are a new student or watching the chemistry class for the first time. You can just raise your hand. And no one, right?
I think nobody.
No one. Alright. So let's begin the chapter, okay? Let's begin the chapter, acid, bases and salts. So we know a lot of chemical compounds, right? We already studied a lot of chemical compounds and we already know about a certain lot of chemical compounds. Now I can classify these chemical compounds as acids, bases and salts, okay? So the chemical compounds can be classified based on the chemical properties, okay? The chemical compounds can be classified based on the chemical properties as three types. As our chapter name indicates, acids, bases and salts, okay? These are the three classification of our chemical compounds, okay? Alright. So, how can we classify a chemical compound? based on the chemical properties of these compounds. So write it down. Based on the chemical properties of the chemical compounds, we can classify the chemical compounds into three types. That is nothing but acids, bases, and salts. Okay, you already know what does acid, base, and salt means, right? Am I right? Do you know what is salt?
Yes.
Acid and base? Yes. Alright, please repeat again. Alright, I'm going to repeat that again. We have a lot of chemical compounds, right? We know a lot of chemical compounds. Now, how do we classify the chemical compounds? So, based on the chemical properties, each compound will be having their own chemical properties. Okay, each compound will be having their own chemical properties. So, based on that chemical properties, we can classify the chemical compounds into three types. That is nothing but acids, bases, and salts. That's it. Simple, right? Yeah, the chapter starts with a simple manner, but as it goes on, we'll be having a lot of chemical reactions. Okay, no worries. I'm not getting you scared, so no worries. Okay. Did you get it? Did you get it? Now let's study them individually. Let's get an idea what an acid and base is first. Okay. So first of all, let's talk about the acids. Okay. So have you ever felt like this when you bite into a lemon or an orange? The sour taste. How do you feel? How do you feel when you bite a lemon? Have you ever tried that? Everyone is like, ma'am, we don't know what a lemon is. Is it like that? Have you ever experienced the sour taste in your tongue?
Very sore, yes.
Very sour, right? Yeah, I can give a challenge. Can you eat a lemon without any expression, without making any expression in your face? Can you do that? How many of you can do that? Just raise your hand. If you can do that, if you can eat a lemon without giving any expressions, so many of them. Can you do that? Can you eat a lemon without any expressions? Really? Yes. Who can show that to me right now? Who have lemon in your home? Everyone will be having the lemons, right? So who can show me that without any expression? Who can do that? Everyone is running to get the lemon, I think. Someone is really running over there to get the lemon. Yes, if you have a lemon, get it and come back. Quickly get it and come back. If you have a lemon, yes. I'll give you 1 minute. If you have lemon in your home, just quickly grab it and come back. Okay, quick. Let it be quick. Don't turn off your cameras, okay? So quickly go and come back.
That has some issues with the
Camera, alright, no worries. I ate lemon for dinner? You ate lemon as dinner? I cannot believe that. Yes, ma'am, can you please pin the first one over there? Wait a second, okay? Yes.
This one?
Who's that?
Zaid.
Zaid, wait for a second.
I want to pin him.
Yeah, pin him, ma'am.
Yes.
Let me check. Will be. Yeah. Eat it. Eat without any expression.
Oh.
Oh. I'm getting that sour taste and he doesn't have any expression at all. That's really sour, right? How can he eat like that? He's eating like, ma'am, it's like so sweet.
Someone is like, ma'am, my mom will yell at me.
Alright. The chemistry class is so fun, right? If they yell at you, you should like, this is the chemistry class. So we are like this in our class. Yes. Alright, so I can see those faces are very good. Good job, Said. Good job. So why do we get the sour taste? That was my actual question. Why do we get the sour taste while we eat the lemon? Or while we bite into a lemon? Why are we getting the sour taste? Can I have a guess? Can I have a guess?
I wanna.
Yes, unmute someone, ma'am.
Okay, yes.
Why? Why are we getting the
Nantana.
sour taste?
Nantana.
Nantana?
Yeah.
Yes, Nantana. Do you have any answer?
Hello.
Hello, Nantana.
Oh, you are not audible.
Yes, we have so many answers in the comment box. That is really great. Very good.
I think Nantana is not audible.
Nantana is not audible for us, so let's go towards the next person.
Okay, let's ask Mugda.
Mukta. Mukta?
Mugda.
Yes, why do we get the sour taste when we bite into a lemon?
Because lemon juice is an acid.
Yes, it's due to the acid which is present inside that lemon. So how can we define a lemon? How can we define a lemon? Not a lemon, acid. Okay, how can we define an acid? So acid is the chemical substance which have a sour taste. So whenever a chemical substance will be having a sour taste, I can call that chemical substance as an acid. So acids will be having sour taste. That is the first characteristic of our acids. Okay. Alright, so that is due to the acid which is present in our lemon. So acids will be having sour taste. That is the first property of the acid. Is it clear for you? Is it clear for you? So acids are the chemical substance which have a sour taste. Which have a sour taste. And which are the other fruits you know that will be having a sour taste? What are the other fruits that you know? What are the other fruits that you know which are sour in taste? Let me know in the comment box. Let me know in the comment box. Amla, then tiny grapes, unripe grapes, right? Apple contains acid, yes. Orange, then tamarind,
Vinegar.
vinegar. Talking about the fruits and someone is like vinegar, ma'am. Vinegar will be having sour taste.
Lime.
Fruits, okay. Fruits. Raw mango, then gooseberries.
Cranberries. Yeah.
Free mangoes.
Green mangoes.
Green
no, free mango actually.
Free mangoes.
I think.
Yeah,
Typing
free
error.
mangoes. What I mean by free mangoes? Yes, might be green mangoes. Raw mango, then some berries, cranberries. So tomato, yes, we'll be having so many fruits which will be having a sour taste, right? Sour taste. So all those fruits will be having acid in it. All those fruits will be having acid in it, which is why they have a sour taste. So fruits with a sour taste is due to the acids which is present in them. So acid is the chemical substance which will be having a sour taste. Keep this in mind. Never ever forget this. Okay.
Yes, ma'am.
Is that clear?
Devananda has.
Yes, Devananda. Do you have any doubt?
Yes, Devananda.
Yeah. I have a doubt related
Yes.
to acids, ma'am. We also learned a definition for acids that they release H plus ions. So, like, can we say it like that?
Yes, I'm going to explain that. Okay, I will explain that. Not in this session, but later class I will explain that. Okay, if I explain like it will liberate H plus ions or OH minus ions, you will be like, what is H plus and OH minus ions, ma'am? So we'll go by a stepwise manner. Okay, I'll make you understand everything. No worries. So the first thing, they will be having a sour taste. They will be having a sour taste. Now let's check out some natural acids which is present in our natural sources. So the first one, someone said about the vinegar, right? Vinegar. Which is the acid present in vinegar? Do you know that? Which is the acid which is present in vinegar? Which acid is present in vinegar? You can just comment it. Comment it. Oxalic acid?
Nitric acid.
Really?
No,
Oxalic acid? No. Lactic acid?
Acetic acid is the
Most one?
most one, yes.
Yes, let's unmute one, ma'am.
Somebody is like HCl.
HCl in vinegar? Really? Yes, ma'am. Unmute one for me.
Yes, let's unmute. Ion.
Iron. Iron, which is the acid present in vinegar?
Ayan, you will get a notification.
Ma'am, acetic acid.
Acetic acid, very good. Acetic acid is the one which is present in vinegar. So whenever you cook something, tell your mom like, Mom, get me some acetic acid, and she'll be like wondering, oh, my child is really learning chemistry over there, and let them surprise. Okay, so tell her like, Mom, get some acetic acid. Instead of vinegar, you can just use acetic acid. Okay, so acetic acid is present in vinegar. Will you forget that again? It's not oxalic acid, it's not HCl, it's not any other acids. It is acetic acid. Vinegar, acetic acid. Okay, vinegar we will use always, right? In our household works, we always used to do. Always use the vinegar, right? So you have to know what's the acid present in vinegar. It is nothing but acetic acid. Yes, CH3COOH, definitely right. We are going to detailedly study about acetic acid in the 4th chapter. In the 4th chapter, we have a detailed view about acetic acid. Okay. Yes, so vinegar will be having acetic acid. The next one, orange and lemon. We all know that, right? If you get wrong with that, I'll scold you really. Which is the acid present in orange and lemon? In citric fruits. Orange and lemon is called as the citric fruits, right? Now guess which is the acid. Citric fruits will be having what kind of acid? Ma'am, unmute one for me.
Okay.
Let's
unmute ash.
Yes. We have a lot of right answer. Ma'am, should we learn this table? Yes, definitely you have to. You have to learn this. There is no excuse in that. You have to learn this. Okay, no excuses. No other excuses. Yes, ma'am. Who is that?
Ash.
Ant. Yes. Which is the acid present in orange and lemon?
Citric acid.
Citric acid. Very good. Citric acid is the one which is present in orange and lemon. That's why they are called as citrus fruit. Okay, citrus or citric fruit or citrus fruit. Okay, orange and lemon are citrus fruit. That is why they will be having citric acid in them. Citric acid. Okay, we are talking about acids in fruits and natural sources. Okay, keep that in mind. Next one, tamarind. Tamarind. Tamarind, which is the acid present in tamarind? Yes, Evelyn, very good. Only Evelyn gave me the answer. Not only Evelyn, we have so many answers. Very good, children. Very good. So now time to unmute one. Yes.
Okay, let's unmute. Devanarayan.
Devanarayan. What is the acid present in tamarind?
Tartaric acid.
Tartaric acid, very good. Tartaric acid is the acid which is present in tamarind. Okay, both of them starts with a T, right? You can just remember like that. Tamarind, tartaric acid, it's quite simple, right? Both of them starts with the letter T. Alright, very good. The next one is tomato. Tomato is the next one, okay? Tomato is the next one. How can we draw the tomato? Do you know how to draw the tomato? Yeah, somewhat like this, right? And the green. Yeah, looks like an apple, right? Yeah, the leaf of this one will not be like this.
Is that a tomato?
Yeah, that's a tomato for me. Yeah, definitely that's tomato. It's perfect tomato, right? Yeah. So tomato, that is tomato. So what's the acid present in tomato? Do you have the answers, ma'am?
Yes, we have.
Tomato acetic acid.
No.
Acetic acid is present in vinegar, right? And how can you tell like acetic acid is present in tomato, ma'am? Really? No, never.
We have mixed
Unmute
salts
one
like
for me, ma'am.
malic acid or salts. Okay, yes, Abdul Hana.
Hanan. It's almost like a round, right?
Oxalic acid.
Yes, oxalic acid. I'm still drawing the tomatoes. Yeah. Anyway, It is nothing but oxalic acid. So tomato is in a round shape, right? Tomato is in round shape. So oxalic acid. It's in an O shape, right? So oxalic acid, ta-da! Tomato will be having oxalic acid in it. Okay, just remember the shape of the tomato, which is a pretty O, right? Like O. So oxalic acid.
Ma'am, they only need to study these names only, right?
Yes.
No need to any descriptions about
No,
acids.
no descriptions, just the names of the acids which is present in those natural sources, okay? Just the names are enough. Oxalic acid in tomato, tartaric acid in tamarind, citric acid in citrus fruit, and acetic acid in vinegar. That's it, okay? Oh, just remember, someone gave me the emojis in the comment box. That is how tomato looks like, ma'am. It's not like this. Anyway, these are my tomatoes, okay? So looks like an O, right? Oxalic acid. Now what about curd? What about curd? The next one, curd. Curd.
Already our comment box have answer.
Comment box is filled with the answers. Yes. Now time to unmute one.
Okay. Let's unmute. Region.
Also give me the answer for ant sting, okay?
Region.
Region. Region,
Yes,
which is the acid present in curd?
it's lactic acid.
Definitely it's lactic acid. Lactic acid. Very good, very good. So curd will be having lactic acid in it. What about the ant sting? What about the ant sting? If you get an ant bite, you'll be feeling a painful reaction, right? Due to which acid present in that? Due to which acid? Someone is like antacid, ma'am. No. No, not antacid. Yes, very good. That is nothing but methanoic acid. And someone is like, ma'am, that is not methanoic acid, it's formic acid. How can you mistake that? It's formic acid, right? It is formic acid, not methanoic acid. Definitely. The other name for methanoic acid is the formic acid. Okay, formic acid can be also called as methanoic acid. So ant sting or bee sting, honey bee, also having this formic acid. And many other plants will be having formic acid too. So methanoic acid and formic acid is one and the same. It's one and the same. Don't ever get confused with that. Okay. Ant sting will be having formic acid or methanoic acid. Methanoic acid. Okay. So methanoic acid is ant sting. So remember this table. Kindly remember this table. Okay. You have to study this. There is no excuse in that. Please do study this table. Okay. Is that okay for you? Both of them are same. Okay. Formic acid and methanoic acid is one and the same. Shall I move forward? Give me thumbs up. Give me thumbs up.
Yes.
Give me thumbs up.
Thumbs up.
Yes. Very good. Now, acids are nothing but the chemical substance which have a salt taste. All these natural sources had a salt taste, which is why the acids present in them. So due to the acids present in those natural sources, they seems a salt taste. Okay. So that is the first property of an acid. Now let's move forward. They change the color of blue litmus paper to red. Okay. What is litmus paper now? The litmus paper are the papers which indicates whether it's an acid or a base. Okay. If we have a substance, we have to identify whether it is an acid or a base. Okay. We have to identify that. In order to identify whether it's an acid or a base, we have the indicator called as a litmus paper. So litmus paper indicates whether the given substance is an acid or a base. Now tell me, how many types of litmus paper do we have? How many colors of litmus paper do we have? Do we have all the 7 colors in the rainbow? All the 7 colors in the rainbow? Someone is like 14, ma'am. 14 colors are there. 14 variety colors of litmus paper. Yes, Said have a doubt over there. We have the hand rises. Yes, Rama?
Yes, I think it's ant sting out.
Ant sting. Yes.
Yes, say.
Nothing. I got it clear.
Okay, fine. Yes, so
Ansh has
also have
Yes.
doubt. Yes, Ansh.
I have to give. I want to give the answer.
You have to answer this?
Yeah.
Yes, answer it.
Like you asked the question. Yeah. It has like two types.
Two colors. Which are those two colors?
Red litmus paper and blue litmus paper.
That's it. We have two. That is nothing but a red litmus paper and which is that third one?
Red, blue, and purple.
So basically, in order to identify them, we have two. Okay, purple always belong to blue one. Okay, there's nothing like purple over there, and we have other litmus papers too. Okay, other indicators too. We'll study detailing about that. Okay. Now we have two type of litmus paper, which is nothing but blue and red. We'll be having blue litmus paper and red litmus paper. Okay. Now, if we dip the blue litmus paper into an acid. Okay, consider we have an acid over here in my hand, and I am dipping a blue litmus paper into that acid, and that blue litmus paper will turn into red. Okay, for example, over here I have an acid and I have two litmus paper, red and blue. Okay, I have two litmus paper, red and blue. Now I have an acid. If I dip blue litmus paper into an acid, okay, consider only the blue litmus paper. I will explain the rest. So consider the blue litmus paper. Okay, I'm dipping a blue litmus paper into an acid. So that blue litmus paper will turn into red if it is an acid. Okay, if the given solution is an acid, the blue litmus paper will surely going to turn into red. Okay, blue into red. Red always indicates a dangerous condition, right? Red always indicates dangerous. So our acids are pretty dangerous. Not like all the acids, the concentrated acids are pretty much dangerous. Okay, so you can remember like that. Turning into red will be an acid. Okay, turning into red will be an acid. Remember like that. And we dipped a blue litmus paper and turned into red. What happens if I dip a red litmus paper in an acid? What happens? So if it is an acid, blue litmus paper will turn into red. So if I dip a red litmus paper inside an acid, nothing changes. Okay, no change takes place. Red litmus paper remains red. Red litmus paper remains red. Okay, so if I have an acid, if we dip a blue litmus paper, it will turn into red. That's how it is indicated. Okay, indicated. Now we have certain example for the acids. Okay, laboratory acids. So HCl, H2SO4, HNO3 are the common acids. Okay, they are some of the common acids. Example for the acids. Okay, is this clear for you? Any doubts, anyone? It's time to unmute one for me. Yes, ma'am.
Alice has any doubt? I think Alice.
As do you have any doubt?
No.
No
Okay.
doubt. Let's unmute one, ma'am.
Okay. Let's unmute. Gauri.
Gauri.
Gauri, we know.
Gauri Vinod. Gauri, can you please unmute?
Yes, ma'am. Can you hear me?
Yes, I can. So, Gauri, what happens if I dip a blue litmus paper inside an acid?
Changes its color to red.
Changes its color to red. Very good. Unmute someone else, ma'am.
Okay.
Very good.
Hosanna.
Hosanna.
Yes, ma'am.
What happens if I dip a red litmus paper inside an acid?
It remains red.
It remains red, no changes happen. So seems like everyone understood this concept. Am I right? Am I right or wrong? Give me thumbs up if so far it's clear.
Okay.
No doubts, no worries.
Haripriya has any doubt?
Haripriya, do you have any doubt?
No.
No doubts. Okay. Now, acid part is over. Now, what about the bitter gourd? Bitter gourd. How many of you like the bitter gourd actually? How many of you like the bitter gourd? Raise your hand if you like the bitter gourd actually.
There are.
There are
Yeah.
students who like the bitter gourd.
Yes.
Yeah. Personally, I don't like. Do you like mom? Ma'am.
I don't
I'm
like.
really confused. The ma'am and mom. Yeah. Ma'am, do you like the bitter gourds?
No, definitely
Not at all, right?
Not at all.
Ma'am, for every acid, does it turn red? Definitely. If it is an acid, it will definitely turn into red. No doubt. When cooked, it is fine. What about juice? Bitter gourd juice. It's so much healthier, right? Bitter gourd, even though it's very healthy, the bitter taste, that disagreeable bitter taste. How can they eat it? I don't know. So bitter gourd will be having a bitter taste, right? Why? Why do they have the bitter taste? Why can't they have the sour taste? Why can't they have the sour taste? Because there is no acid present over there. So there is no sour taste. Now why does they have the bitter taste?
Somebody's like, because it's called bitter gourd. That's why it takes it.
No, it's not like that. It is bitter. That's why they are calling them as bitter gourd. Okay, it's not like it is bitter gourd. That is why it is bitter in taste. No. It is bitter. That's why it is called as bitter gourd. Yes.
We have answers.
We
actually.
have answers just because they contain the bases. Okay, these fruits or vegetables will be having base in it. So the thing is, bases. Bases will be having bitter taste. Okay, so acid had a sour taste, whereas our base will be having bitter taste. If something is bitter in taste, they will be containing the base in them. And not only the bitter taste, they are soapy to touch. Soapy to touch. Okay. And someone is like, ma'am, this bitter gourd is not soapy to touch. Okay. I'm talking about the base which is present inside that bitter gourd. Not talking about the bitter gourd. Okay. The base will be soapy to touch. Okay. It is bitter in taste. It is soapy to touch. And for your luckiness, you don't have to study those names of the bases which is present inside that bitter gourd. Okay, if you study that, your mind will be like out of the world. Okay, it's so difficult word. So luckily, you don't have to study that. All the thing that you have to remember is just bases are bitter in taste and they are soapy to touch. Okay, soapy to touch. How does this soapy touch feels? It's something slippery, right? The soap is something slippery. That is how the base feels like. Okay. We have the hand rise over there. Is that a doubt?
Mugda, I think.
Mugda, do you have any doubt?
Actually, I replied that.
I replied that. Okay, fine, no worries. Yes. So bases is the chemical substance which are. What is that?
I wanted to ask why tomato is acidic in nature.
Because of the oxalic acid present inside that tomato. We have learned that, right? Tomato will be having oxalic acid in it. That is why, already replied. The tomato will be having oxalic acid in it. That is why it is sour in taste. Alright. Yes. So bases are the chemical substance which are bitter in taste and soapy to touch. Soapy to touch. Okay. And yuck.
Our students are like, now you just tell anyone to eat that without any reaction.
Now drink this. Drink the bitter gourd juice or bitter gourd without any expression. Can you do that? It feels like, I cannot do that. But there are children who likes the bitter gourd actually. I don't know how, but they like it. Alright, teacher, what about perfume? Perfume, have you eaten perfume? That will be poisonous, okay? Don't ever get drinked with the perfumes. Don't do that. Yes. That's it, right? Tanya, do you have any doubt?
Tanya, yes.
Yes, what is that?
Okay, so like lemon, the green one.
Green lemon,
Because,
yes.
Okay, what else? Yeah. So like if you cut it open and it like half piece, and when we put it outside for a while, it gets bitter. So does lemon actually contain both acid and base?
No, never. No, it is due to some chemical reactions. Okay, it is not like base is present in that. No, it is reacting with the air and it is reacting with the moisture and it is getting, it is undergoing a chemical reaction. That is why it is getting a better taste. Okay, it is not due to the base present in it. No base is present in lemon. Okay, it's only the citric acid. All right.
Somebody actually, Humaira had to restart her laptop, so missed a little bit.
Can
Slides.
you wanna show
But
the...
we are going live now.
Yeah, we are going in YouTube live over there, you know that? So you can just go and watch over there, okay?
Don't worry, you will get all the slides.
Alright. So bases are bitter in taste, soapy to touch. Keep that in mind. Now what about the litmus paper? What about the litmus paper? Okay. They changed the color of a red litmus paper into blue. Red into blue is base. Okay. So base and blue starts with a B, right? If it is turning into blue, that is base. Okay, turning into blue is base. Okay, an acid and it will turn into red. Always acids will be having a bit dangerous conditions. So dangerous always indicates the red. So turning into red is acid. Turning into blue will be base. Okay, remember that. Remember that. Okay, blue. Base, blue, base. You might be getting confused with that, but don't ever get confused with that, okay? Don't ever get confused with that. So I have seen so many children struggling with this. Okay, they will be always confused. They will be like, turning red litmus paper into blue indicates acidic condition. Never. Okay, turning into blue is base. Turning into red is acid. Keep that in mind. Never ever forget that. Okay. So blue, base. Okay, turning into blue is basic in nature. So here we go with a base. Okay, I have a base over here and I am dipping red litmus paper inside a base. Okay, what it will do? It will convert into what? The blue litmus paper. If I dip blue litmus paper into base, it will convert into what? They are like, don't confuse us, man. Yes. Tell me, what happens if I dip a blue litmus paper inside an acid? A blue litmus paper inside an acid. Or not the acid, base, okay? Yeah, we are talking about the base, right? Yes, definitely no change. It remains the same. Blue litmus paper remains as blue. Okay, blue litmus paper doesn't have any change. Now what about red litmus paper? Turning into blue indicates base. Okay, so the red litmus paper will turn into blue. Red litmus paper will turn into blue. Okay, so remember always, let me change the color of the pen. Red into blue indicates base. Okay, and blue into red indicates acid. Okay, you should not forget this. Okay, red into blue, base. Blue into red, acid. Okay, now what happens if both of the litmus paper are not changing its color? I have a liquid in my hand and I dipped blue litmus paper, no color change. I dipped red litmus paper, again no color change. Why? Someone is like salt. The remaining thing is salt, right? So they are like salt, ma'am. No. Salts, we have salts of two types, acidic salt and basic salt. Okay, the salt can be acidic and basic. Never get confused with that. I'll explain that. Okay. In the later classes, I will explain that. Now, what happens if the both of the litmus paper are not changing its color? They will be neutral in nature. They are neutral. They are neutral in nature. If both the litmus paper are not changing its color, that liquid will be a neutral. Can you give me an example? Can you give me an example? A common example. A common example of neutral solution or neutral liquid. Not the base, not the base, not the acid. Okay, it will not be a base, will not be an acid. It will be in a neutral condition. It is not an acid, it's not a base. Definitely, very good, very good. Water is an example. Water is an example. Water is not basic in nature, not acidic in nature. If we dip a red litmus paper in a water, red remains red. And if we dip a blue litmus paper inside of water, blue remains blue. So water is a neutral liquid. It's a neutral liquid. Now let's play some animations. Okay, let me check how many of you really understood this concept. Let's have some animations. Yes, sir. And after that, we have to discuss about the corrosion and rancidity. Right after this animation, we'll discuss the rancidity and corrosion. Okay? Yes. All right. Supposedly. What are the beakers that we have? We have 4 beakers filled with the different solutions. The first one will be having vinegar in it. The second one will be having lime water. Third one, soap solution. And the fourth one, HCl. Okay, vinegar, lime water, soap solution and HCl. And yes, sir, you can play it. Watch carefully, okay? Watch carefully. Pause it. So we are taking the blue litmus paper, okay? Let's first take the blue litmus paper. Sir, pause it. No, before that. Yes. So now let's unmute one, ma'am. Please unmute one.
Let's unmute.
Gershon.
Gershon, yeah.
Gershon.
Yes, ma'am.
Yes, what happens if I dip a blue litmus paper inside the vinegar? What do you think will happen?
Ma'am, blue litmus paper, ma'am.
Remains the same?
No, ma'am, it turns red.
It turns red. Why?
Ma'am, because blue litmus paper reacts with acids.
So vinegar is an acid.
Yes, ma'am.
Which is the acid present in vinegar? I have told you, right? Never ever forget that. And how can you forget that within seconds? It starts with the A. Acid.
Acid.
No! Acetic acid, right? Oh, yes.
Acid
Now I
acid.
remember. It is acetic acid, okay? So dip it.
Yes, ma'am.
So it turned into. Yes, I played. Stop. It turned into red. Blue litmus paper turned into red. That means our vinegar over there is acidic in nature. If blue litmus paper turns into red, that will be an acid. That will be an acid. Keep that in mind. Okay. So blue litmus paper turns into red. It is acid. It is an acid. Now what about the lime water? Yes, ma'am. Unmute one. What about the lime water? What happens to the blue litmus paper if I dip the blue litmus paper inside a lime water? Archisha. What happens?
Yes, ma'am. It's an acid because lime has citric acid.
So will it turn into red?
Yeah.
Alright, so play it. Yes, suppose that's it. Why is it not turning? Why it is not turning? We have studied lime will be having acid, citric acid in it. And why does the lime water is not turning its color?
It's because it's diluted in water and water is heat.
No, this is not the lime water that we drink. Okay, lime water is that is another substance. Okay, Lime water is not what you meant by the mixing the lime inside the water and putting sugar in it. It's not that lime water,
Not a
okay?
lemonade.
It is.
They are saying it's a lemonade like that.
It is not lemonade, it is calcium hydroxide. Calcium hydroxide. The other name for calcium hydroxide is lime water. Okay, so it is calcium hydroxide. Yes.
Okay.
Yes, the next one. Yes, sir.
Oh, yeah.
No, before that, unmute one.
Aisha.
Yes.
Aisha Arif. Okay. Yes, ma'am.
Yes. Who's that?
Aisha.
Aisha.
Yes, ma'am.
Aisha, what will happen to this blue litmus paper if I dip into a soap solution? Is soap solution as an acid or a base? Soap solution is a base. Are you sure?
Yes, ma'am. It's soapy in texture.
Soapy texture. So soap must be in a base. Very good, very good. Sir, dip it. Dip it, sir. Yes. So blue remains blue, right? Blue doesn't have any effect on that. Blue remains the blue. So soap solution, blue remains blue because it is a base. Now what about HCl? Unmute one, ma'am.
Okay, Muhammad Hashman.
Hashman.
Ma'am, it will change to
It will change into red. Why?
it's acid.
It is an acid. Very good, very good. Yes, sir. You can dip it now. So it changes into red. So positive. Yeah, it changes into red. Very good. So the first one is vinegar. I'm going to repeat that again. Okay, I'm going to repeat that again. Listen now carefully. The first one is vinegar, which is acidic in nature. We have acetic acid present in it. Okay. Acetic acid. We have acetic acid in vinegar. We have acetic acid in vinegar. And so it will turn blue into red. That means it is an acid. If the litmus paper is turning blue into red, that will be an acid. That will be an acid. Now talking about the lime water. Lime water is basic in nature. It is not the lime water that we drink. It is calcium hydroxide. Okay. It is calcium hydroxide. Okay, calcium hydroxide. CaOH twice. Calcium hydroxide. Calcium hydroxide is also called as lime water. So this calcium hydroxide is a base. It is basic in nature. It's a base. Okay. So blue litmus paper reminds the blue. Blue litmus paper reminds the blue. And soap solution again it's a base. Okay. Soap solution is again a base. So blue litmus paper turn into nothing. It will remain as the blue. We are going to learn about the soap detailing. Okay. We will learn the soap detailing now. Now HCl. HCl is an acid. So it will turn blue litmus paper into red. Now we have to check whether the lime water and soap solution is really basic in nature. We have no assurance about that, right? We are sure that they are not acids. They are not turning into red. So we are sure that they are not acids. But till now we are not sure that they are basic in nature. So what will we do? What will we do? In order to make sure both of them are basic in nature, what can we do? Ma'am, is it flaked lime? Yes, flaked lime. It is also called as flaked lime. It is also called as lime water. Yes. Sir, can you play that again? No. Play that. Yes. So, let's remove this and bring about the red litmus paper. Okay, let's remove that and bring the red litmus paper again. So, ma'am, unmute one.
Okay. Let's unmute Mahira.
Mahira,
Yes,
what do you think will happen now?
ma'am, it's my turn to.
It will turn into blue just because they are basic in nature, and we are making sure that the lime water, calcium hydroxide and the soap solution is basic in nature. Yes, sir. Let's dip it. And can you see the color change? Definitely. The red litmus paper turned into blue just because they are basic in nature. So always remember, if the litmus paper is turning from red into blue, it is basic in nature. Okay? Yes. And if it is turning blue into red, it is acidic in nature. Okay? Can we touch lime water and soap solution to see if it is a soapy in nature? Yes, you can feel that soapy nature of soap solution, right? Also lime water will be soapy in nature. Yes, definitely. So that is about the litmus paper. Yes, sir, you can remove it and play the another one. We have one more animation. Okay? Yes, sir. We have three test tubes. A, B and C. Okay, let's mark it as A, B and C.
Oh no.
Alright. So we have three test tubes A, B and C. Okay, three test tubes with A, B, C. Alright. Now we don't know whether these three solutions are acidic in nature or basic in nature or neutral in nature. We don't know that. Okay. So what will we do? In order to identify whether it's an acid, base or neutral, what will we do? What can we indicate that by? What can we do? Comment it. Quickly comment it. We don't have time.
Yes,
Quick.
teacher, we have that comments. Let's use.
Can we just drink that and taste it as whether it's a sour in taste or bitter in taste? If it doesn't have any bitter or sour taste, it will be neutral in nature. Can we do that? So don't ever do that, okay? Don't ever drink an acid and check for the acidity. Don't
Not
do
even
that.
touch.
Okay? Don't even touch an acid, okay? It will burn your hand. It's dangerous, okay? I have told you, acids are dangerous. Don't drink it, not touch it, okay?
Fiza was like, we already saw the answer, ma'am.
We already saw the answer, and why are you keep asking that again? Yes, by using the litmus paper. Now let's bring the litmus paper, sir. We have the blue litmus paper. Yes, sir, you can dip it now. Yes, sir. Okay, now. Pause it. And now tell me which is acidic, which is basic, and which is neutral in nature. Test tube A, test tube B, test tube C. Which one is acidic, which one is basic, which one is neutral? Ma'am, unmute.
Yes, let's unmute. Zaid.
Zaid.
Mom, A is acidic
A is acidic. Why?
because the blue litmus paper turned red.
Blue into red means acidic in nature. So A is acid. Yes. A is acid. Now what about B and C? What about B and C? Unmute another one, ma'am.
Yes, of course.
Either
No,
no,
you.
Zaid.
Next one, okay?
Let's unmute.
Yes.
Benita.
Benita. Now tell me about B and C. Is it basic or neutral in nature?
Basic.
Both of them are basic in nature? How can you be that sure? Both of them are basic in nature. What if one is unwanted?
Mustard.
What if one is unwanted?
Have any change color?
We have to check it with a red litmus paper too, right?
Yeah.
That's it. We are not sure whether the B and C is basic or neutral in nature. Both of them are not giving color in its solution. No color changes. So we still don't know whether it's basic or neutral in nature. Okay? Neutral in nature or basic, we don't know that. So let's bring about our red litmus paper. Yes, sir. Here we have the red litmus paper. Let's dip it. Watch it carefully. Yes. Yes, sir. Now tell me which is basic and which is neutral. Yes, ma'am. Unmute one for me.
Yes, let's unmute Rajeshri.
Rajashree. which is basic and which is neutral? A is already acidic in nature, so it turned blue into red. Now there is no color change in red, clearly indicates that it is an acid. Now what about B and C?
B is basic in nature since red litmus paper turns to blue.
That's it. And what about the C?
It's neutral in nature since there's no change in color.
Very good.
Yeah, red to blue.
Very good, that's it. So in test tube B, the red litmus paper changed it into blue. That means our B is basic in nature. It is a base. And C, it doesn't give color both on red litmus paper and on blue litmus paper. No color change for both of those litmus paper. So C must be neutral. C must be neutral. Okay. This is how we identify whether the given solution acidic, basic or neutral in nature. Is this much clear for everyone? Give me a thumbs up. Give me a thumbs up if it's clear for you. A double thumbs up. We have talked about little topics, right? We only talk little topics or just small topics in this class. So you have to remember everything. You have to study everything. Okay. If this much is clear for you, you can remote say. If this much is clear for you, can I move forward with the last topics, the topic from the last chapter? Topic from the last chapter, corrosion and rancidity. Okay. Shall I move forward with that? Very good, very good. So the topic that we have to discuss from the last chapter, okay, this topic is not from this chapter, from the last topic, okay, from the last chapter. That is nothing but effect of oxidation reaction in everyday life. In everyday life, we are seeing so many chemical reactions, right? I have told you in our daily life, we are seeing so many kinds of chemical reactions. So we have to study some of the oxidation reactions which is happening in our day-to-day life or everyday life. What is oxidation reaction, by the way? Ma'am, that is deleted. Yes, I know this is a deleted portion. So some of the students have really pleased me to teach this. So I'm going forward with that. Okay, some of the students doesn't have this topic. So it's okay to study this, okay? It's okay. We have the answers in the comment box. It is the addition of oxygen or the removal of hydrogen. Very good. You remember the oxidation reaction, right? And we have to learn some of the oxidation reaction in our daily life. So here we have the corrosion. So the first thing that we are going to learn is nothing but corrosion. Okay, do you know what is corrosion? Do you know what is corrosion? Let me check. How many of you know the corrosion? Just raise your hand if you know about corrosion. We have already studied this in lower classes, right? You know that what corrosion is, right? So corrosion is a simple topic and we are not really getting immersed into that topic, just the basic things, okay? We are going to talk about the just basic top things about the corrosion and we are going to wind up the chapter, okay? Wind up the session. Yes, so corrosion is nothing but it's a process by which a metal surface is attacked by a certain substance such as air or water. We have a lot of metal substances in our home and in our surroundings. Am I right? We have so many kinds of metal substances. And after a long time, corrosion is a long time process, okay? It's a slow process. So corrosion happens it takes time. Corrosion takes time, okay? So if that metal is reacting with air and also the moisture and also with the other gases which is present around that substance, it will just corrode. It will damage itself, okay? The surface of that metal will be damaged by the chemical reaction with the air, water and any other gases that is present in the atmosphere. So corrosion is nothing but the destruction of the metal. Destruction of the metal is known as corrosion. We already know that, right? Corrosion causes many destructions, and we have so many kinds of things around us, like a bridge. Bridge will be made up of the metals, especially the iron, then the ships, then the vehicles, and also so many other materials. If that material corrodes, what happens? Causes a total destruction, right? So corrosion is a dangerous destruction process. It damages the metals. It damages the surface of the metals. Okay, that is nothing but corrosion. So corrosion is a process where the metal gets corroded by the reaction with the air and water, and also the gases present in the atmosphere. Okay, that's nothing but corrosion. So corrosion is an oxidation reaction because it is reacting with the oxygen that is present in the air. So it is an oxidation reaction. Okay, it is an example for the oxidation reaction. Always remember, corrosion is an example for oxidation reaction. Now, the most common example of corrosion. What is the most common example of corrosion that you can give? The rusting of iron. You have seen this, right? Rusting of iron is an example for corrosion. It's an example for corrosion. So before it really get corroded, it looks like this, right? The shiny surface, it will be having a shiny surface. And this iron will react with the water. Rusting of iron. This is called as rusting of iron. And this iron, let me change the color of the pen. So this iron will react with the oxygen that is present in the air. Oxygen that is present in the air, and also reacts with the water that is present in the atmosphere, the moisture, and it will get rusted. We have to study the chemical reaction for this, but not in this chapter. Okay, but not in this chapter. It comes in the metals and non-metals. The chapter metals and non-metals. There we will detailedly study about the rusting of iron. But in this small topic, the corrosion, you only have to remember that the iron will react with the oxygen and water that is present in the air, and it will rust. So this is called as the rusting of iron. So rusting of iron is an example for corrosion, and corrosion is an example for our oxidation reaction. Was that clear? Was that clear for you? So it causes a total destruction. Okay. So after so many years, that metal will be a total waste. We cannot reuse that metal again. Okay, it causes a total destruction. We cannot reuse that again. Okay, it's destroyed. So corrosion means destruction. Alright, so rusting of iron is an example for corrosion. And we have so many other examples. Tarnishing of silver. Tarnishing of silver. Have you ever seen this? If you have ornaments made out of silver, it might be getting black color, right? It will get black color day after day. And also it takes time, okay? Not happens within 2 days. It takes time, okay? After years and months, it will just turn into black color. That's called as tarnishing of silver. Tarnishing of silver is also an example for the corrosion. Okay, tarnishing of silver. And also we have a famous example of copper. Okay, where's copper? Wait for a second. And here we go with the copper, the Statue of Liberty. What is this process? What happened really to the Statue of Liberty? Was it green color before? Was it green color when they made the Statue of Liberty? Was it green in color? No. Then which color was that? I'm really feeling like I'm floating in the air, right? Yeah. So, which was the color of the Statue of Liberty when it is made? It was reddish brown in color. That's the color of copper, right? It's a statue made out of pure copper. So copper will be having a reddish brown in color. Now after They reacted with the air. The copper reacted with the air around that and it turned into green. Again, an example for corrosion. Again, an example for corrosion. Okay. And someone is like, ma'am, it's not destroyed yet. Why? We have the exceptional cases, right? So it will not destroy like that. It takes years and years. I have told you, right? It's a slow process. It takes years and years for that. And it is a green color now. It's again the tarnishing of copper. Tarnishing of copper.
Taj Mahal is not.
Taj Mahal. No, changing Taj Mahal, that was due to the acid rain. Okay, that was due to acid rain, not the metal. Okay, so Taj Mahal is made up of marble, right? Not any other metals. Marble is not a metal. So it's made up of marble. No, pink.
No pink.
It's not pink, it's green. Okay, fine. That was clear, right? So these are all examples for the corrosion. Corrosion. Now the thing that we have to study is nothing but a rancidity. Rancidity is also an example for oxidation reaction. Okay. Ma'am, is this the oxidation reaction? Definitely. The corrosion is an example for oxidation reaction. They are reacting with the oxygen that is present in the air. So they are all example for the oxidation reactions, and we will really see the chemical equations and chemical reaction for those in the upcoming chapters, but not in this topic. Okay, not in this chapter, but upcoming chapters will be having a detailed view about that. We are going to learn everything. Now the rancidity is daily happening in our life, right? Rancidity, you have came across with this rancidity, right? Rancidity of foods, rancidity of oil, rancidity of fats. Am I right? Ma'am, unmute someone.
Okay.
They are really like rancidity. We haven't seen that in our life.
Okay. Let's unmute. Amna Fatima.
Amna,
Yeah.
Yes, ma'am.
have you ever eaten a rancid food?
No, ma'am.
No, never?
No.
Yes, ma'am. Like rancid food is like it's bad.
Yeah.
So have you ever tasted it accidentally?
Yes.
Accidentally you have tasted it, right? And how does it feel?
It feels like it's bad, like a bad taste.
Bad taste. And what about the smell?
A bad smell. Like
A bad smell. Very good. That's it. So we all know what is rancidity. That is it. Okay. Nothing more, nothing less. Rancidity is a process of slow oxidation of oil and fat present in food materials, resulting in the change of smell and taste in them. Okay, if some food is getting rancid, it will change its smell and it will change its taste. Okay, that is nothing but rancidity. If we keep open this potato chips or any other materials, it will react with the air and it will change its taste, it will change its smell. Okay, and it also takes the days. Not happens within seconds, not happens within minutes. Time taking process, slow oxidation process. It's a slow oxidation process of oil and fat present in food. That is nothing but rancidity. Rancidity, okay? Simple, right? That was simple. It is the destruction of food. Destruction of metals was the corrosion, and now the destruction of food materials is rancidity. And they are all example for the oxidation reaction. The oxidation reaction. Okay. Is it clear for you now? The oxidation and the corrosion and rancidity.
Yes, Shridhi, I saying to prevent that only the chips are tightly kept in a plastic.
Yes. Now we have to learn how can we prevent the rancidity.
Yes.
How can we prevent the rancidity? That's really that we are going to study right now. Okay. Yes, ways to prevent the rancidity. The first one, vacuum packaging. What is vacuum packaging? Vacuum packaging. That's nothing but airtight. Okay, we are airtight. If we just keep open that potato chips, we will tightly pack that again, right? Will we do that? Will you do that? Or just keep that like open it in the air? Will you do that? No, right? You just tightly pack that together again. That is nothing but vacuum packaging. Removal of the air. Okay, we are cutting out the contact with the air. We are cutting out the contact with the air, so they will not react with the oxygen that is present in the air. They will not react. The food items will not react with the air. So we are tightly packing them with a plastic cover or any containers. We will close it, right? We will avoid the contact with the air. That is vacuum packaging. Vacuum packaging. Okay. Now, refrigeration. We always do that, right? We have the refrigerator, we have the fridge. We always keep the food inside that, right? So we will refrigerate at the lower temperature, Okay. Refrigeration is again an example how to prevent a rancidity. Now, using nitrogen gas in packaging. Really? Can we use nitrogen gas in packaging? So what do you think that you see in that Lay's or Kurkure packets, the potato chips packets? Do you think that's a pure air inside that? And you will be like, we are buying the air packets instead of potato chips. Instead of potato chips, we are buying the air packages. Is it like that? Because we'll be having only 2 potato chips inside that package. And rest among all of them will be the gas. That is nothing but our nitrogen gas. Okay, if we will fill the chips packet or any other food packaging materials, we will fill them with the nitrogen gas. Okay, we are filling that with the nitrogen gas, not just any other ordinary gases. And this nitrogen, will it react with the food items? No, right? The nitrogen gas is inert gas. Nitrogen is an inert gas. It will not react with our food materials. So it is safer to use the nitrogen gas inside the package, and it will prevent the food from decaying or prevent it from the rancidity. So nitrogen, okay. Nitrogen. We will be filling the chips packets with the nitrogen gas and storing in a dark place. Instead of storing that in an open space, we can store that in a dark place, prevents the rancidity. And using antioxidants. Okay, oxidation is happening over there, right? And what happens if we use the antioxidants? Again, antioxidants. Okay, it is just against the oxidation. So it prevents the oxidation and prevents the rancidity. So using antioxidants is the way to prevent the rancidity.
Now, if you are using vacuum packaging in chips, then why put nitrogen gas inside it?
We have different conditions, right? We have different kinds of foods and we have different kind of packaging. The one is vacuum packaging and another one is nitrogen gas packaging. We have different kinds. It's not just one, right?
Okay. Our Devananda has it.
Devananda.
Yes.
Ma'am, I understand the reasons that you told, but then for the last one which you told, storing in a dark place, what is actually the benefit?
So it will not react with the sunlight.
Oh, okay.
At the temperature, the sunlight happens, right? It also depends.
Yeah.
So we will keep that in a dark place. Yes, that's it. So this is how we will prevent the rancidity. Was that clear for you? The corrosion and rancidity? Thumbs ups. Yes. Give me thumbs up. No one is giving me the thumbs ups. Everyone is like,
No,
give me
they
the
will
thumbs
not give
ups.
thumbs
They are giving me the thumbs ups. Did you understood everything? Someone is like 85% air and 1% chips, man.
I'm pretty sure all of them has that comment, like we are buying nitrogen packages, so we are
Yes.
buying nitrogen gas for free.
Yes, the nitrogen gas. We are paying for the nitrogen gas instead of the chips. We are paying for the nitrogen gas. Yes. So was that clear for you? Is today's session so much clear for you? Any doubts regarding any topics from today's session?
Ma'am, is flushing with nitrogen gas an example of using antioxidant since nitrogen?
No. Nitrogen is not an antioxidant. We'll be having so many other preservatives, okay? They are antioxidants.
And how does refrigeration helps? That's doubt.
By cooling. If we just cool down the temperature, we can just store that for a long time. That's how refrigerator works.
I think that much are the doubts.
That are the doubts. Okay. Ma'am, can you show the previous slide? Definitely. Ryan City. Okay. I hope that was clear. Now, time for the exam. Our ma'am is so happy over here. So, can you activate the exam? Exam. Okay, are you all ready for that? Are you all ready to attend the exam? Really? They were eagerly waiting for the exam, I guess. Here the chips are fine in India. We
Harpreet is
can count
asking,
exact 5 chips in the packet. Definitely, we can count exactly 5. It will be less than 5 in that packets. Definitely. Justice for chips.
Ma'am, Harpreet is asking, are you not teaching the electronic concepts of oxidation and reduction reaction?
No, it's not there in our chapter. No, electronic concepts, no. The only thing that we have to study in this chapter is nothing but electrolytic reaction. We already discussed that.
Oh,
Electrolysis. We already
her
discussed
school,
that.
Her teacher taught us, so yeah, maybe. But
Alright. Alright. Is that clear?
yes.
Now, time to do the exam. Here we go. Okay, it's activated now. You can just already done 10 on 10. Okay, they already done that. Okay, I'll wait for that. Okay, and we'll discuss it. Got 10 on 10, 10 on 10. Very good. Good job, good job.
Done.
That was really simple topics, right? That was really simple questions. Done 10 on 10, 10 on 10. Everyone got 10 on 10?
That's why I was
Unbelievable.
thinking, yeah.
Or are they following me? Everyone got
Everyone-
not even 8 on 10.
Actually, commented, everyone commented.
10 on 10. How comes?
Ma'am,
Victory!
you are gonna surprise.
Yeah, I'm really surprised. Everyone got 10 on 10.
Everyone. All the comments are 10 out of 10 actually.
Really?
Yes, ma'am.
My eyes cannot believe that.
Yes, everyone.
Yeah, the tears.
You just asked
Finally.
anyone, is there anyone
Is there anyone who got 8 on 10?
or below that 8? No, I think
No one.
I don't know.
Really, the
happened?
tears are coming out from
Oh my
my
God.
eyes.
Everyone. Oh no, there
Ah,
are someone.
We have one.
Yes, we have
Yeah,
one.
that's a huge
Okay.
relaxation.
Maybe some of them
Not
are
relaxed, okay? I'm not relaxed. Okay, you have to score 10 on 10 in next exam. Okay? Yeah.
Okay. I know 6 is also there.
Okay, don't
Yeah,
comment it.
there
Don't
are-
comment it, okay?
Okay.
I was in a thrilled mode.
Mode,
So don't
okay.
comment it. Now everyone is like 6 on 10, ma'am. 8 on 10, ma'am. No, don't do that. Alright. Good job, children.
ma'am,
Just kidding. Oh, that was kidding. They scored 10 on 10.
Oh, Linda is like, no need to surprise ma'am because you are the one who taught us.
Thank you.
Yeah.
So impressed.
Actually, there is a doubt. Why baking soda doesn't have OH minus ion? So how does it turn red litmus paper to blue?
We will discuss that, okay? In the upcoming session. We'll discuss that, okay?
Okay.
Because baking soda is really not base, it's a salt. Okay, it's a basic salt. Okay. We'll discuss that, okay? If I tell that, you will be just confused with that. Ma'am, when you teach 10 on 10. Yes, so ma'am, it's okay, confused. Ma'am, it's okay, so confusing in the exam, even the essays. Alright, shall we discuss it? Shall we discuss the answer? Are you ready or need more time? Who needs more time? No one.
I think that
Really,
we are all
everyone
right.
did that. So here we go, the first question. Tomato is a natural source of which acid? Which acid? Yes, indicate me with the fingers. Ah, very
So,
good. It's nothing but citric acid, right? No! Who said no over there? Someone really unmuted and he couldn't hold on and see. He was like, ma'am, completely wrong. It's not citric acid, it's oxalic acid, ma'am. He was so uncontrollable. Alright, so oxalic acid. Now, lactic acid is present in? Ah, very good. It's present in curd. And which acid is present in tamarind? Which acid is present in tamarind? I told you to remember the T, letter T, right? Tamarind and tartaric acid. Very good. And he's like, just remember that. Alright. And I thought like after saying this question you will be like that. And none of you was like that. Everyone got 10 on 10. I thought you will feel like that. Mama. Alright, which of the following will turn blue litmus paper red? Blue into red. It will be an acid. It should be an acid. So, it must be vinegar. Vinegar, right? Did anyone felt like this after seeing this question? Not even one?
No, but
Now my condition is like that. Oh my god. Alright. Which one of the following will turn red litmus paper blue? Ah. That is nothing but baking soda. Rest of the vinegar, lemon juice and curd will be having acid present in it. Okay. It is not lime water over there. It is lemon juice. Okay. It's lemon juice now, not the lime water. Okay. Our sir got just confused with that. You said lime water is basic in nature. Now lemon juice is acidic. How comes? So this lemon juice, okay, not lime water. So second one is the right answer. We have the hand eyes over there.
yes.
The second one.
Region.
Region.
I just forgot.
Ah.
Lime water is blue litmus paper.
What was that?
So, ma'am, is lime water blue litmus paper?
Lime water is basic in nature, not the lemon juice. Be clarified with that. Lime water. Slaked lime. Lime water or calcium hydroxide is basic in nature. So it will turn red litmus paper into blue. Okay, red into blue. It's basic. Clear? Ma'am, do you not want to get 10 on 10? Definitely, I want you to. You have to get 10 on 10. That's my happiness, right? Ma'am, I was supposed to get it. Alright. So, here's a famous quote. Do more of what makes you happy. Okay? So, you have to be happy always, no matter what. Find something and be, ma'am, chemistry makes me happy. Definitely, very good. Chemistry makes us happy. Everyone happy, right? Yes, chemistry is a happy subject. So, do whatever you want to do. Just be happy the way you are. Okay? And thank you so much. Thank you so much for listening to me. And thank you so much for studying hard. And I'll see you in the next class. Until then, take care and bye-bye. Good night.